So, hi everyone. As Björn said, my name is Nicolas, and I'm heading the analytics team for our main product, Upgrade. So in this talk, we'll see how we manage at Accedo to crunch roughly 400 million rows of logs every 20 minutes using two fantastic tools that are Rabbitmq and Amazon Redshift. But I've been told that I'm like the social guy in the team, so I'd like first to interact with you and make a quick survey. So can you please raise your hand if you know Rabbitmq, at least what it is? Okay. And Amazon Redshift? Nice. So thank you. And let's start. So why do we want to crunch this data? Well, we have one goal, which is giving application owners insights about their app. Like how are the users using the app? So for instance, we need to know how many users are using the app and how often they come back. So for that, of course, we need some data. We need to collect it in an efficient way, if possible, and then to store and process it. So let's start with the data. As you may remember from the Alexei's presentation, we have Upgrade, which is our CMS, and this CMS is serving content to devices on various platforms through an HTTP API. So the devices, they communicate with Upgrade using HTTP requests, and those requests contain information about what the device wants. So for instance, an app might just tell us that the user closed it. So Upgrade is not only serving content, it is also keeping track of the application usage. And it actually does that for a lot of devices. And I really mean a lot. As of today, we receive connections from roughly 10 million unique devices every month. Those devices, they generate over 300 million valid requests each month that are converted into one log or one event, roughly. So that's the raw data that we use. That's those 400 million rows of logs, we have to store them and then process them to extract meaningful information out of it. But before we crunch it, we need to collect it. And at Accedo, we have to do it in an efficient way, given the traffic we receive. And I have nothing more efficient to offer you than procrastination in this case. So, may sound a bit incompatible, but with logs, it's actually perfectly right. Let's pretend that you are the machine that is there. So you are receiving a request from a device. What does the device want? Just an answer to the request. So compute the answer and send it back. Take care of the log that you might want. Take care of it later. So how can you achieve that? Well, just write the relevant information on a piece of paper about the request. Let's pretend that you're not a very advanced machine. And put this piece of paper in a big basket that is somewhere else. So this thing. And then someone else will eat the things that you put in this basket. And I really say someone else, not you. So this thing is actually even better than procrastination. You are delegating stuff. You're not doing it yourself. So how is that interesting? Well, you can achieve scalability provided that the basket scales as well. You don't have unnecessary long transaction times. You only do what you have to do, so you don't even put extra load on the API machine. It's just doing its API job, sort of. So you also achieve concern separation. But I know, what is this basket? So maybe you have guessed. Say hello to Rabbitmq. So Rabbitmq is the basket. and it's a rather big one that can contain a lot of messages in its queues. And then it distributes those messages to whoever might ask for them. It is very popular. We have been using it in production for 10 or 11 months now, and I love it, and in the team we now trust it a lot. We love this thing. So what happens once a message reaches Rabbitmq? Well, honestly, nothing happens at all. Nothing until we have another process that we like to call the log consumer that will eat the logs out of the queue and then insert them into whatever local database that we want to use. And it will insert them in a clever way. More on that during the question session, if you will. But you might wonder, what is this log database? At Accedo, we have, or rather we had, knowledge into MongoDB and MySQL initially. So we quickly excluded MySQL for storing logs and first started to do that into MongoDB. So this was rather good, but up to a certain amount of traffic. At this threshold, when we reached this threshold, the costs skyrocketed while the performance got worse and worse. So 1 year ago, we had to look for an alternative, something better than that. And then we discovered Amazon Redshift. So what is Amazon Redshift? Well, it's a SQL-based database that is stored in the cloud and that is powered by a lot of magic that make it very fast. It is able to store an enormous amount of data while keeping the costs low and the performance high. So this might sound like a scam. I know. Let's check the figures then. We made some performance tests. And the figures that you're about to see don't come from Amazon. We made them. So we implemented the system and then we checked how it was performing. And we compared it with MongoDB. So I told you that Redshift was fast. Well, in our case, in our system, it is 123 times faster than MongoDB. From roughly 3 hours of processing time, we went down to a minute. So that's rather good, right? But there is something else that is even better. The disk space consumption. We managed, by moving to Redshift, to cut it by 20. So this Redshift is a bit magic, but it has some limits as well. And one of them is actually its ability to answer to simple questions. Like if you want to extract a limited subset of the gigantic amount of data it's storing, it's rather slow. MongoDB was doing better with that. So it's not great for every use case, but price and feature-wise, it's definitely a fantastic tool that we love as well.